Today it's talking about pests and diseases in alfalfa, which is tough. A lot of the alfalfa is really one of the um, only major crops that we have around here that is a perennial. And when we're dealing with control on perennials, on a perennial crop versus annuals, it really changes some of our management recommendations. And then the other thing to think about with um, diseases and pests of alfalfa is really the bottom line as well. And the alfalfa alfalfa market generally doesn't warrant a whole lot of additional inputs, but in some cases it does. And so again, we have our Q&A feature as well as the chat. I will be monitoring both of them, so feel free to throw anything up when you start or when the questions come up. See. All right. So first, and I know I'm talking about diseases and insects, but I am a plant pathologist. And so I'm mainly going to talk about diseases. I think diseases are a lot more fun. Also, insects are big. Pretty much anyone can see them. The diseases, they're a little bit tougher to identify. So, but what is a plant disease in the first place? And we have a textbook definition that a plant disease is a malfunctioning of host cells and tissues that results from a continuous irritation by a pathogenic agent or environmental factor and leads to development of symptoms. That's a lot of words. But what does that really mean? Well, to me, a plant disease is anything that prevents a plant from reaching its maximum potential. And again, that maximum potential varies for different plants. If it is alfalfa, you want that good regrowth. You want a good stand. But if you're growing roses, well, you have a different aim in mind for growing those. So I think of a disease as anything that prevents the plant from kind of being the best that it can be. Now, in my definition of a disease, that includes environmental things. And so whether that is if you have some soil compaction that's leading to root problems or a nutrient deficiency or flooding, a lot of these things, they still prevent that plant from reaching its maximum potential. And so to me, I consider those to be diseases. Those are just abiotic diseases, not our biotic diseases. But I'll get into that a little bit more later. But in order for disease to occur, at least disease by a living organism, whether it's an insect disease, an insect pest, or a fungus, we need to have these three components. So we need to have a conducive environment, a susceptible plant, but then we also have to have that pest or that pathogen kind of all occurring together, and that is known as the disease triangle. And one aspect of this disease triangle here that is kind of missing, so it almost should be a disease pyramid almost, is timing. And timing is really it's very critical when we think about disease development. And if we have a conducive environment and a susceptible plant, but the pathogen's not here, well, we're not going to have disease occur, so we don't have to worry about it. If we have a conducive environment and but we don't have and we have the pathogen but not the host, again, we are not going to have disease. So we need all three of these things to occur kind of at the same time. And talk about the disease triangle and really or kind of the disease pathosystem. And as we think about how disease develops, it really tends to be a function of how much do these three components overlap on one another. And if we have a situation like is displayed here, we'll have light or really or no in theory no disease that should be occurring. Now, you may also have a situation where there is a little bit of an overlap occurring, and in that case, we're going to have moderate disease. Typically, this is when people first start to notice that something is wrong. They're seeing that maybe the on one end of the field they're seeing some chlorotic plants or seedlings aren't coming up, something, but they're starting to notice something. What we really don't want to have happen is when we have a mass overlap of these three components. And this is when we can have very, very severe disease that can lead to all sorts of problems, massive yield loss, massive major stand reduction, all sorts of problems. And so we've talked about disease development, and so the amount of disease that we get is a function of how much these three components overlap. But the overall impact, so I don't care about how much disease is out there. What I care more about is what is the overall impact on the host. And if we have a lot of disease at the end of the season, which we always do, I am not worried about that. In general, alfalfa can be a little bit different, but if we have a lot of disease right close to harvest, it's not going to be an issue because we're cutting that, we're harvesting it. The plants they've more or less done their job. Now, what I care a lot more about is what is the impact on the host and how much how much of a problem are we going to see? And if we kind of take that same example of thinking about diseases or plants at the towards the end of the growing season or that are nearing harvest, um, again, there can be a lot of disease, but it's generally not going to have a major impact on the host. Now, conversely, say we have a lot of disease, a lot of seedling disease, and you have maybe it's a Phantomyces root rot or a Phytophthora or Pythium. We have a lot of seedling diseases that can occur, and if those seedlings die, well, that plant never has a chance to grow at all, and so there the impact is very severe. And I always like to talk about plant health as a continuum, and we have the the things that we have plants that are weak, we have plants that are very strong. No different than humans. Plants have an immune system. It's different than humans, but they do still have an immune system. And as with humans, when we are otherwise strong and healthy, diseases, it's going to be hard for them to really cause a major problem with us. But now if we're really weak and or real not even just weak, but just tired, really burned out, staying up late, not eating right, not doing the things that are important for health, well, then our immune system gets weaker and it's a lot easier for even just a common cold to knock me out for maybe like a week. Whereas if I was otherwise healthy, the cold would come and it would pass in about a day. And so really, I always talk about it's yeah, this plant health continuum, and we so often in plant pathology we talk about compounding stresses to plants. And often when we have plant death occurring or major yield issues, it's not just one thing going on. There are a couple things going on. Often some environmental problems, you know, maybe there's flooding, or maybe it's drought conditions. In Nebraska, we have both of those, extreme heat, or even a cold spell, something like that. So maybe there's some sort of environmental factor that weakens the plants, but then a disease comes in and we start to see even more problems occurring with that. Now, another thing that I like to talk about during this section is, our environment is changing. And the USDA plant hardiness zone, every year it gets moved further north a little bit. When I first started in the diagnostic clinic, Nebraska was very solidly, or kind of the Lincoln area was very solidly in the 5A horticultural zone, and now we are close to 6B. So we're in that just 7 years. There's been a shift north of pretty much one entire horticultural zone. And as those environmental conditions change, that's going to change the effect to our pest triangle. And so maybe we have a situation where our environment has become more conducive to a certain pest. Now we're going to have a lot more disease that can occur, and even disease or new diseases that we haven't previously seen. Now, on the other side of things, as our environment gets a little bit warmer and potentially drier, well, our environment's not going to be as conducive to some other diseases. And so some of these diseases that may have historically been problems in your area, in the next 10, 15 years, maybe even sooner than that, those problems will go away. They will be replaced by new ones, of course, but those problems that we're used to will go away just because of that environmental change that has occurred. Now, I talked about, how diseases can be caused by living things or non-living or environmental type things. And so we like to refer to those as biotic and abiotic diseases. And so an abiotic disease, that's again some sort of environmental condition impacting plant development. Sun scorch, nutrient deficiencies, maybe a misapplication of a herbicide, soil compaction, all sorts of things are included in these environmental factors. And in my time in the diagnostic clinic, about 90% of the samples that I have received, the main problem has been something environmental. Yes, I can find disease on there, but I can find disease on anything. Same as if any of you would go to the doctor and just say, keep testing me, they would find something. Maybe maybe it's something kind of important, but it's probably not. But there is, a little bit of disease. There's some disease that's out there everywhere. But most of the problems that we tend to encounter are these abiotic or environmental factors. And now, the other type are our biotic diseases, and those are caused by living organisms. And so the organism grows, multiplies, and spreads. That's very, very important to think about. And we have our fungi and bacteria and nematodes, viruses. Those are the pathogens. Again, we also have our insect pests. The and another, or even if there's deer or some other large animal that gets into the field. I guess growing up, I grew up on a farm. We had a small farm, and grew alfalfa and had a small herd of cattle. And there were about 3 years in a row where apparently I could not build good fence, and every year there was at least one cow that got into the alfalfa and would kind of tromp through it. And that could be an example of a biotic disease. Now the joke was on the cow eating 100% alfalfa, got pretty bloated, and then those cows ended up passing. But that's neither here nor there. So, as we think about the things that cause our abiotic diseases or the non-living diseases, I like to break them down into three main factors: our physical factors, our chemical factors, and then our mechanical factors. The physical factors primarily are going to be the weather, is that's kind of what I think of a physical factor. And so temperature, moisture, UV radiation, the weather. Maybe it's a big storm, a hailstorm, something like that. Chemical factors primarily tend to be pesticides. It's the biggest thing that we tend to fight. But we also have air pollution. The if there would be any sort of, with the increased prevalence of wildfires and having more heavy smoke days in this part of the country, that could be an abiotic disease, or that could be a chemical factor causing an abiotic disease. And then the mechanical factors are really going to be, I mean, everything else, whether that is running over as we're going through the field, if we're running over stuff with our tractor, you name it. Now, that's different from our biotic disease causing agents. And these are really the pests and pathogens. We have parasitic plants. Not a whole lot that this group would have to worry about. I know in the southern part of Nebraska, we do have issues with dodder. And in case anyone who's not familiar, dodder is this kind of orange parasitic plant. It doesn't produce its own chlorophyll. It actually steals it from the host plant. Um, but in addition to parasitic plants, we have, again, insects, mites, nematodes, algae, viruses, molecules, viroids, all sorts of stuff. And I also kind of like people to think about the size, how big these things are. And as I mentioned, I'm spending a lot more time today talking about diseases than the insects. But again, insects are bigger. And even if we just look at this previous picture here, we have some aphids here on this bottom picture. And yes, this image is very much blown up, but you can still see adult aphids with the naked eye. So you can spot them. Compare that to our plant pathogens, and they are much, much smaller. And so this is just our stereotypical plant cell. It's more or less a box, has a thick cell wall, and then inside of this cell wall, we have our main pathogen groups. And starting with kind of the smallest ones, we have our viruses. And these are, um, and our viruses are smaller than any organelle, and than anything inside of a plant cell. That really small size of viruses allows them to very easily migrate between cells and go systemic or cause infection throughout the entire plant very quickly. As we move up in size, the next one that we have are our bacteria. Bacteria are single-celled organisms. Again, much smaller than a lot of things in the plant cell. This circle that is down here at the um, in the lower right hand side of the plant cell, that's the nucleus. And our bacterial cells are smaller than the nucleus. And when I used to do some research with bacterial diseases, in order for me to ensure disease, what I would try to do is I would try to inject 10,000 bacterial cells into a single plant cell. So that just gives you an idea about how much smaller these bacteria actually are than the plant cells themselves. Now, the bigger pathogen groups are the multicellular pathogen groups. We have our nematodes and our fungi. Nematodes, we have a nematode head right up here, kind of at the top, that's poking its head through that cell wall. Nematodes are microscopic worms, non-segmented microscopic roundworms that primarily live in the soil. However, they can feed on any plant part. So we can have nematodes as root disease causing root issues. Also, we can have nematodes that can cause foliar issues as well. In alfalfa, there are no reports of any foliar nematodes, but there are some root some root attacking nematodes that will attack alfalfa. Oh, and then the last group that I want to talk about are our fungi. And so fungus here we can see kind of the one of its arms starting to reach into that plant cell. And fungi, depending on how you want to measure it, an argument can be made that the largest, actually the six largest organisms on the planet Earth are fungi. They're in the Pacific Northwest, at two places in northern Europe, and then also in kind of Michigan and Minnesota area, but primarily in Michigan. We have fungal colonies, and it is the same fungus that has grown across hundreds of miles. And if we're actually going to try to test the biomass of that fungi, it ends up being in the tons. And so again, fungi, very, very impressive. A lot of the fungi that people tend to be most familiar with are mushrooms, but most fungi don't produce large fruiting structures like that. And so just also need to do a little bit of terminology. You know, it's you did sign up for a university-led thing, so there has to be some terminology here, right? And I've talked both diseases and pathogens. And a lot of times people will use these two terms somewhat interchangeably. I don't like them to be used interchangeably. Technically, they are two very different things. So that disease, again, is the malfunctioning of host cells, blah, 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 whatever prevents the plant from reaching its maximum potential. That is a disease. The pathogen is the entity that causes the disease. So the example that I have is the disease anthracnose of alfalfa. And so the disease is anthracnose of alfalfa, but the pathogen is Choletotricum trifoliae. And here we have, in this kind of middle picture, we have some of the common symptoms that we see with anthracnose, that shepherd's crook type appearance of the wilted stem, and then some of those kind of silvery diamond-shaped lesions on the lower stem. But then the picture that I have on the right over here that almost looks like it has a bunch of like spikes sticking out of it. Those spikes are the actual anthracnose fungus that I would be looking for if it were to come in. And now using these the same disease, some more terms, we have signs and symptoms. And so a sign is visible evidence of the pathogen or the pest or the insect. But whatever the problem is, it's something that you are actually seeing. Now, a symptom is just a change in appearance of the plant or a change in function of the plant. But so if we just have, and so again, we have, this is more anthracnose, but we have that wilting appearance with the light tan or straw colored leaves. That is just a symptom of anthracnose. When something comes into the diagnostic clinic, in order for me to confirm a pest, I need to be able to find the actual sign. And so I need to actually find the setae, so they be able to actually see that fungus or bacteria, see that insect, whatever it is. I need to actually see it, not just looking at things, because you know, spend a lot of time talking about common symptoms and the things that are, you know, most diseases, they once you've seen it once or twice, you tend to have a pretty good idea of what the disease is that you're looking at. But as we have differences in weather patterns, as we have new varieties that are entering the market, those symptoms can change. And the pathogens, you'll hear me say this again, but the pathogens can't read. They don't know what they're supposed to do. We think they know what they're supposed to do. But really, if you're doing diagnostics purely off of symptomology, that is a recipe for failure. There can be some success, but eventually you are going to be wrong because, and I can tell you this, anthracnose is far from the only thing that can cause individual alfalfa plants to wilt and kind of have that kind of get those straw colored leaves on them. So, and you guys are going to get, you'll have access to all of these recordings, but just some common symptoms that we see. And so again, the symptoms are just the change in appearance. But if you can accurately identify symptoms, you can go that can really help you identify what the possible disease is. And so looking at knowing the difference between a leaf spot and blight. And so a leaf spot is just going to be single spots on the leaf, but leaf blight is where that entire leaf kind of almost like wilts and kind of fades away. So again, knowing these common symptoms, very important. What I tend to look for much more often are the signs. And again, so the signs are the actual evidence of that pest. And that's what I need to be able to find on samples that come into the diagnostic clinic. You know, if it's the pathogen or a bacterial pathogen, I'll see some bacterial ooze, so that bacteria kind of streaming out of it. Maybe I'll see some fungi that that's growing on the tissue that tends to be associated with lesions. Maybe I'll find eggs from an insect pest, or even poop or frass from the insects. But again, those signs are very, very important when actually confirming a disease. Now, talked about biotic and abiotic diseases. In my opinion, the most important thing for disease management is being able to differentiate injury caused by a biotic disease or an abiotic disease. And so is this injury caused by something living, an organism that we can control, or is it the wider environment that we really don't have a whole lot of control over? And the best way that you can differentiate abiotic from biotic diseases is by looking at symptom distribution. And looking at symptom distribution across three scales. And so starting off at the entire field, and then looking at the individual plant, and then finally on the individual leaves, it becomes much, much easier to do any sort of diagnostics in the field. And so again, as you're in the field, you're thinking about symptoms that may be occurring. Maybe we have some kind of patchy things that are showing up. Um, Maybe, as we have in this picture on the lower right hand corner here, we have tire tracks that you can see. And this is actually dollar spot on turf, but that fungus is being tracked across the lawn by those tire tracks. And as we're thinking about field distribution, we really want to be looking for patterns. And in general, diseases and pests don't like patterns. They tend to show up much more randomly, um, where you'll have patches or pockets throughout the field that are affected, as opposed to nice patterns. And I'll go into some of these patterns a little bit more. But as we're thinking about field distribution, one of the very important things to think about is overall site operations, especially when we are dealing with a perennial host such as alfalfa. Knowing what we've done not just this year, but in previous years, and so knowing what chemistries were applied in previous years, if there is any soil modification, maybe there is some liming that was done a few years ago. Knowing that disease history becomes very, very important with our perennial crops. And the other thing, as we're looking for patterns, one of the things that we may see is that there is, there's some sort of pattern that tends to look like it is associated with an adjacent landscape or an adjacent field. And again, the diseases tend not to, they tend to be very, very random. If you, the first picture on the far left, where we just have a straight line across, that is going perpendicular to the rows, where we have injury occurring, diseases, pests, they can't follow straight lines, or they can't follow straight lines very well, is what I should say. And so you wouldn't see as uniform, of a distribution like that. In the picture that we have in the middle, yeah, it's worse way on the left, and then we do have an area right here that's kind of bad, but not as bad. That could potentially be disease, or could potentially be insects, or really anything that is moving into the field from outside of the field. One of the biggest things that we tend to see this sort of distribution with is some sort of herbicide injury. And if we have a drift situation, often that drift is worse at the field edge, and as we move into that field, symptoms will dissipate as the chemistry, or as the amount of the chemistry that the plants got tends to disappear. Or maybe we're seeing something right by the field entryway. And that's the image that I have here on the far right that's supposed to be the entryway. But at the field entryway, a lot of problems can occur. We have a lot of compaction. Um, maybe there are chemicals that are dumped there, or you're cleaning out your sprayer in that area, and so you're leading to there may be some other contaminants in the soil involved along with that compaction. And I know we should all be good stewards and clean our equipment as we're moving from field to field, but farmers don't have time. And to go and clean your tires moving from between fields takes a lot of work. But tires spread a lot of diseases from field to field. And so looking at that field entryway can be a great spot to kind of first look for new things. Now, some other, distribution patterns. Again, what was previously done at the site. Um, it's the and so knowing your planting history. If half of your alfalfa field this year is has historically been in a corn soybean rotation, but then the other half of the field has historically been alfalfa, those plants are going to look different under the rotated area versus the area that's been continuous alfalfa. So that previous use can really affect the current appearance. Um, but this sort of pattern distribution is what I tend to think about for disease and also for insects as well. It's not going to be, across the entire field. Maybe very large areas of the field, are kind of clumped, but I would call this just an overall distribution pattern where we're seeing it throughout the field, but it's not every plant. In some pockets, it's a lot. In the middle of those pockets, it's a lot worse than it is at the edge of the pockets. Now, we can also have these irregular patterns that are associated with topography. Maybe we have low spots. And so in these areas in the field, the water tends to pool there. Or it's an area that has a little bit higher clay content, so it holds the moisture a little bit longer. That can really cause some problems. Or maybe it's a hilltop, and so we have some higher elevation, and so maybe this area doesn't get as much moisture as the neighboring parts of the field. And one of the big keys to know, is this distribution that we're seeing, is it caused by a biotic disease or an abiotic disease, is uniformity. And if you are seeing something that is evenly distributed across the entire field, that is a sure sign that it is going to be some sort of biotic, or apologies, some sort of abiotic cause to the problem. The first image that I have on the right, that in that situation, maybe we were dealing with compaction, and so the tire tracks that drove down those two rows, and then the rows outside of the tire tracks were fine, but then as we turned back and came back down the field, now we had some more compaction issues. The image that we have on the right is much more common if we have some sort of sprayer mishap. And so maybe our fertilizer tank, one of the nozzles isn't calibrated properly, and we're applying twice the rate of nitrogen as we would want to. Well, that's going to cause some problems, but that issue will remain throughout the field, but it's going to be continuous. Maybe it's every 15 rows, we're going to have one where we had that sprayer problem. Again, these very uniform patterns, very, very key to making that determination. And then just other field operations, maybe whether it's the row, or if we're seeing a lot of issues in end rows, could be a problem. Concentric rings, if that's often can point to some sort of water issue, maybe we have too much moisture. If it's a center pivot, if it's a center irrigated field, potentially we may even have some sort of issue with the well, so we're having that water leak. Now, we've looked at the field distribution, but now we want to look at distribution on the plant. And different pathogens, different diseases, different nutrient problems, they tend to attack different parts of the plant. And so knowing, are we seeing symptoms on the root or the crown? Or are we seeing symptoms in the lower canopy? Or is it the mid canopy? Or is it the upper canopy? Or are we only seeing symptoms on the flowers? Again, different pathogens, different nutrient deficiencies, they tend to cause symptoms on different parts of the plant, depending on what that specific problem is. And finally, we want to include the symptom distribution by looking at the individual plant parts. And so where on the plant part, so in this case, the leaves, where are we seeing injury occur? And the one that I have here in the the one that's on the top on the left side here, we have very uniform spots on there that are all the same size, all spaced about the same distance apart. A lot of uniformity there. That is very unlikely to be disease. That's most likely some sort of pesticide issue. Maybe we have some sort of leaf scorch that's occurring where we have the leaf margins are burning. Or maybe we have some chlorosis or yellowing that is occurring that maybe is associated with the veins. Or maybe we're only seeing chlorosis between the veins. And all of this really matters. The two images, or the two leaves that I have on the far left, those are really what we tend to expect for both for distribution patterns for diseases and insects. The one on the bottom that kind of has more chewing, that very common for our insect pests. And then the other image on the far left, or on the far right, that has a bunch of spots on the leaves, but they're different sizes, and so some are larger than others. They're not all on the same part. They appear to be fairly random on the plant. That is very, very typical of one of our biotic diseases. Okay. So I spent a lot of time talking about biotic and abiotic diseases. Now we'll actually go into some of the problems that you may encounter in your alfalfa production. And it's there's only one insect pest that I'm going to talk about today, because at least in Nebraska, there's really only one insect pest that we worry about in alfalfa. And so we'll get there eventually. But the first disease that I wanted to talk about is this is not the order that I thought I had stuff in, so bear with me. But spring black stem and leaf spot. So this is a fungal disease caused by Phoma medicagus. But this disease, the pathologists are not clever namers. If your alfalfa in the early spring when it's cool and moist has stems that are turning black, chances are it's spring black stem. Um, this disease really tends to only be an issue that affects the first harvest. Typically, by the time we get to that second or third cutting, then environmental conditions change that where that fungus is no longer terribly active. Again, it's favored by cooler and moist conditions. And as far as what to do about this thing, it's really harvest early if leaf drop becomes excessive, and you will see that as a common thread across these diseases. Now, some of the root rots can be very, very problematic in alfalfa, especially when we get into some of our older stands. Stands that are, when stands are a one year old, maybe even 2 years old, they tend to be pretty healthy. But once we start getting into, years 3, maybe even year 4 or 5 of that stand, there's been a lot of time for diseases or insects to attack that crown tissue. And when I see root rots in alfalfa, sometimes it's a single pathogen, but more often than not, I am finding a whole bunch of different things in there. And when I split a stem and it looks just like this, I can routinely pull out fusarium. I can routinely pull out rhizoctonia. Sometimes I can pull out anthracnose. Maybe there's some bacteria that I can find. There are some nematodes, but I tend to think about most of the root rots in alfalfa as being a part of an, a greater complex where it's not just one disease causing the problem, but it's multiple diseases that are all attacking the same part of the plant that are causing these issues. And we tend to see a lot more root rot on plants that are under other environmental stresses. Again, they're weakened by something else, and now these root rots are really able to come in and take over. Um, one of the most common things that we see causing this root rot tends to be winter injury, actually. And what do you do about it? There's not a whole lot, unfortunately. It's not fungicides are not going to be effective. The best thing to do for any one of our root rots is really just to reduce crop stress by maintaining proper soil nutrition, and then also making sure that we're cutting the alfalfa um, at timely periods. Now, I mentioned that most of the root rots come as a complex. Aphanomyces, though, this is one that I will see on its own. And Aphanomyces it's not actually caused by a true fungus. It's caused by an oomycete, and so that's one of our water molds, like our Pythium or Phytophthora. But one of the nice things about Aphanomyces is it has fairly distinct symptoms as it affects the seedlings. And so the seedlings emerge, but then those cotyledons will become kind of chlorotic or maybe even have a purple tint to them. And that can be a very easy way to identify Aphanomyces root rot. Other thing with Aphanomyces is the seedlings, once they die, they still tend to remain standing for at least for a little while. Whereas if you have something like Phytophthora or Pythium, when we have one of those root rots, there we tend to have a very rapid collapse of that plant tissue. Summer black stem and leaf spot, very, very common in Nebraska, really across the Great Plains. It's caused by a Cercospora fungus. We tend to see these small circular spots that develop on both the top and the bottom of the leaves. And then as the spots progress, eventually defoliation, the plant will start to defoliate at the bottom of the plant, and that defoliation will work its way up the stem. But as the name suggests, summer black stem, this one is favored by hot and humid conditions. And so the weather that we have in the summer, very conducive for summer black stem and leaf spot. What do you do about it? Well, if we have excessive leaf drop, it's going to be harvest early. Again, that's really the main biggest thing that we can do. And now we do have some other foliar leaf spots that we see on alfalfa. I don't think they're terribly major problems. On the top right corner picture there, we have rust. Then we have common leaf spot in the middle, and then down at the bottom is downy mildew. But with any of these foliar leaf spots, again, fungicides, you're probably not going to get a good return on your investment for applying a fungicide in alfalfa in most cases. The one time where we do recommend fungicides will be if it's a young stand, maybe like just that has a lot of rust before, like in the fall. And so we want those plants to be really healthy going into the winter, so we don't see some winter death. But for the most part, only thing we can do is just try to harvest early. One of the diseases that I get the most questions about on alfalfa is anthracnose in alfalfa, and that's caused by the fungus Coleoptera trifoliae. One of the problems with anthracnose is it can cause disease at any point in the growing season, and so it can be a seedling disease. It can show up in the end of the growing season as well. While it can show up any time of the growing season, we tend not to see it until after the second cutting. But especially on stands that are 2 or more years old, that's when it becomes much more of a problem. And that is very common with alfalfa. The older the stand is, the more time these pathogens, these insect pests have had to build up populations. And as that stand progresses in age, we just have some more problems that can occur. The stems wilt, you get that nice shepherd's crook appearance, and then on the lower stems, we should have some kind of nice silvery diamond-shaped lesions that tend to occur. Verticillium wilt is another root-borne disease of alfalfa. I don't see it very often in the clinic. I have seen it on a couple of occasions, but it is I see it way less frequently than I see any of our other root-borne diseases. But with verticillium, one of the nice things, at least early on in the infection process, we get these very distinct V-shaped lesions that start at the leaf tip. And then eventually those leaves will die, but the stem often remains green. But then if we pull that stem up and cut it, we'll actually see rings of that fungus, and the discoloration that we see in the stem, that is the verticillium fungus that is growing through there. Now, if verticillium is a problem that you have in your alfalfa fields, you're going to need to rotate away from alfalfa for at least 2 years. Honestly, 3 to 4 years would be quite a bit better. However, there are also some varieties that are at least partially resistant to verticillium wilt. And alfalfa mosaic virus is the most common viral disease that I see on alfalfa. Tends to be vectored by a lot of different aphids, and alfalfa can get quite a few different aphids. Many of them don't cause major problems, but they may vector some disease. But for the most part, when we see aphids feeding on alfalfa, it tends not to be terribly yield limiting. So, and this virus has a very broad host range as well. You can find it on tomatoes and peppers, soybeans, chickpeas, hemp, whole bunch of different stuff. So it's very common out in the environment, which makes it hard to manage. And insecticides tend not to be terribly effective, a terribly effective control for it because we don't get good enough coverage with those insecticides to completely kill all of the aphids. Best thing that we can do for this one is to avoid planting alfalfa near potato fields because potato fields also will get a lot of alfalfa mosaic virus. Potatoes also have a lot of different aphids that will colonize those fields. And so when alfalfa and potatoes are close to each other, it can kind of be a perfect storm for disease occurring. Other thing that we can do is we can plant early at optimal seeding rates, and what that does is this virus can be seed transmitted, but if it is in the seed, that seed is going to be slower to germinate, a little bit weaker. And if we plant early, that encourages a canopy closure earlier in the season, and that's going to shade out some of those weaker, less thrifty plants that may have the virus. Now, the only insect that I'm going to talk about today is alfalfa weevil, because at least in Nebraska, this is the only insect that really tends to matter in alfalfa, or cause. It's the one that causes people to kind of stay up at night. Um, the eggs are laid by the adults in the spring and inside of the stem. And so on the right here, I have a picture we have some adults and then a bunch of different sizes of the different instars of larvae, and then also the nice, very circular hole that they tend to chew through the alfalfa leaf. And then over here on the right side, those kind of orange or yellow orange masses in the stem, those are the eggs that are deposited. Most of the damage for alfalfa weevil tends to occur before the first cutting. Um, However, if we have extensive injury in the field, that damage can delay regrowth, which is going to delay future cuttings, and it will end up reducing yield. Now, controlling these weevils can be a little bit difficult. One of the best things that we can recommend is to monitor population development. And there has been some really great research done, especially at Iowa State University, looking at the growing degree days needed for different parts of alfalfa weevil development. And so in general, the eggs tend to hatch around the 300 growing degree days, but really we should start scouting once we're at about 250 growing degree days. And that early scouting can help tell us, is this problem going to get bigger in the field, or is it something that we can kind of just live with? An early harvest tends to be fairly effective, especially with that first cutting. It not only removes all the food and shelter for the alfalfa weevil, but those larvae are also very susceptible to UV radiation. And so as we cut it, the UV rays are able to get to those larvae much more readily. And in windrows, when we have windrows, that is a prime environment for fungal growth, which we may say that's not a good thing, but there are a lot of entomopathogenic fungi out there. And so fungi that attack insects, a lot of fungi that attack alfalfa weevils. And so once we have those windrows, then the weevils that are in those windrows, it's much more easy for them to be killed by a fungus. And really, with alfalfa weevil, once the plant is about 16 inches tall, we really don't recommend any sort of insecticidal control. Um, it's the it, we tend not to get good enough coverage once the plants get that tall, and people just are not happy. They tend not to be very happy with the control that they get. Other thing that we need to think about with alfalfa weevil is the fact that there are pyrethroid resistance has been observed in western states. Not in Nebraska or in the Midwest yet, but in California it has. So we want to make sure that we are responsibly using our pesticides. Now, if you ever have an unknown and want to send a sample into a diagnostic clinic, help is available. What I will say though is the better quality sample that you send to a diagnostic clinic, the better results you're going to get. If you send me garbage, your results are likely going to be garbage. If you send me a high quality plant sample, results tend to be high quality. And I can guarantee, we've had speakers from South Dakota and Iowa State today. I know the diagnosticians at both of those universities, and they will say the exact same thing. But here is some of my contact information in case you want to reach out. I have a QR code. Other than that, I will take any questions that people may have. Thanks for your time.